We're considering this standard tableau, and here's the corresponding Young operator, written as a linear combination of permutations, or here written in bird tricks. And now we want to determine the corresponding left ideal. So we just take all group elements one by one and multiply them with this Young operator. So identity times Young operator is of course this Young operator. What's 1, 2 times this Young operator? Well, 1, 2 would just twist these two lines here, but then we can undo this in the symmetrizer. So that's also just the Young operator. What is 1, 3 times the Young operator? Let's just multiply 1, 3 with this green expression here, and we get 1, 3. 1, 3 times 1, 2. That's 1 is mapped to 2, 2 is mapped to 1, 1 onto 3. So we get this cyclic permutation, 1, 2, 3. Then we have 1, 3 times 1, 3. That's the identity, and there's a minus sign here. And finally, 1, 3 times this cyclic permutation. So 1 goes to 3, 3 back to 1. We don't have to write this. 2 goes to 1, 1 goes to 3, 3 goes to 2. That's it. Let's call this R. It's just another group algebra element. So far we got two different group algebra elements as results. What happens when we multiply 2, 3 with the Young operator? Let's also just multiply this out here with these green expressions. Then we have 2, 3. Then 2, 3 times 1, 2. So what's that? 1 is mapped to 2, 2 is mapped onto 3, and 3 is mapped back to 2. So it's the other cyclic permutation. Then we have a minus. 1 is mapped to 3, 3 is mapped to 2, 2 is mapped to 3. And finally 2, 3 times 1, 2, 3, what's that? With a minus sign here in front. 1 goes to 3, 3 goes to 2, 2 goes to 1, and that's where it stays, and 3 is mapped back to itself. So there's a third result, different from the previous two, but if we add, say, the Young operator and this R, what do we get? There's an E here and a minus E here, so this goes away, and there's a minus 1, 2, 3, no, sorry, there is a minus 1, 3 here, and a 1, 3 here, so these two go away, and then we keep just the other four terms here. These are exactly the four terms we have down here, just with the opposite signs. So we have minus Young operator plus R. So this is a linear combination of the previous two. And now what's missing, that's the cyclic permutations times our Young operator. Well, what's 1, 2, 3? We can write this as 1, 3 times 1, 2 times the Young operator. But 1, 2 we know here, we can absorb this. So it's just 1, 3 times the Young operator, but 1, 3 times the Young operator that we have here is R. So we get R again, and now 1, 3, 2 times the Young operator. Well, 1, 3, 2 is actually the same as 2, 3 times 1, 2. And then we have the Young operator here, but the 1, 2 we can absorb again. And then it's just 2, 3 times the Young operator. So we once more get minus Young operator minus R. So we actually found a two-dimensional ideal that's spanned by, say, the Young operator and the second element R. So let's write this. L2, no, Y2, L for this normal tableau here with this diagram. That's just the group algebra of S3 multiplied with this Young operator on the right, and that's the span, say, of the Young operator and this R.